power rule. Now I'm going to be giving Mrs. Courier the directions that everyone I know is going to be very good, just wait please, very good in class tomorrow. However, if there's anybody in here that is giving her trouble, you're not working effectively, you're constantly walking around, she's constantly having to talk to you, she will tell me who you are, and you will have at least 2 lunch detentions with me next week. Do you guys understand? So I need you guys to keep that in mind as you choose your behavior for tomorrow and your work ethic for tomorrow when Mrs. Courier is here. Do you guys understand? Yes? Excellent. So 4.7 continued. These are, what we're talking about is we're still talking about multiplication power rules. However, today we're going to be focusing on a power of a power. So let's review the one we already have learned. So that's what we're focusing on today, as a power of a power. So let's review where we've been. I like to review particularly these power rules. I like to review the ones we've done so you have them in your head and you can separate them from new ones. Alright, so the one that we did yesterday is when we are multiplying. So this is our first one. When we multiply numbers with the same base. This is when we multiply numbers with the same base. So for example, I'm just going to use a variable. If I have x to the 3rd times x to the 5th. Somebody tell me, what does the rule tell us to do? What does the rule tell us to do? Aaron? So if you were explaining somebody what the rule is, not what work to do, what would be the rule? Keep the base, so we're going to keep one base. Excellent. And then what? Excellent. And then add the exponents. Nice job. So Aaron's absolutely right. This would be x to the 3 plus 5. So this would be x to the 8th power. And this step right here of showing that addition, that is required. Please make sure you're writing that down. So when you go back to your notes to help you with your homework tonight, to help you with classwork tomorrow, you're going to see, oh, that's right, I have to show that step. Now the reason I'm so adamant about you showing that step is our next power rule is, it's a different power rule, and I need you to keep track of what you're doing with your exponents. That's really the difference, okay? Okay, so my next power rule, this is a power of a power. And I'm going to show you from an expanded form what it looks like, of why the rule is what it is. But remember, I'm expecting you to use the power rule, not expanded form. How many of you guys heard me say that? Frankie, did you hear me say that? All right, you're using the power rules, not the expanded form. Okay? So if I give you, let's do 2 because I think multiplying by 2's is the easiest. Let's say I have 2 squared all raised to the 3rd power. So I want to show you how this rule, why this rule is what it is, and then we're just going to use it. Okay? 2 squared all raised to the 3rd power means 2 squared times 2 squared times 2 squared. How many of you guys agree with that? You guys cool with that basic idea? Okay. Well, what does 2 squared mean? Kira? That means 2 times 2. Well, I have to do that 3 times. So 2 squared times 2 squared times 2 squared is the same thing as 2 times 2 times 2 times 2 times 2 times 2. Well, what does that look like in exponential form using just one base and one power? Angela? 2 to the 6th power. So somebody tell me, if I started with 2 squared, all raised to the 3rd power, and if you notice, the base and the first exponent are in parentheses, the second exponent or power is outside the parentheses, okay? What do you think would be the rule? I keep my base, because we always keep one of our bases. How did I get from 2 squared all raised to the 3rd power to 2 to the 6th? What do you suppose I do with my exponents? Mia? Yeah, we multiply them. This is going to be 2 times 3. So when we have a power of a power, we're going to write this down, but I want to say this out loud. We keep one of the bases. That's always going to be the case. We keep one of the bases. And in this case, we multiply the exponents when we have a power of a power. All right, so let's write that rule down. So here is rule number 2. This is when we have a power of a power. So what we do is we keep one base, and then we multiply the exponents. So if I wrote that as like a formula, it would be a to the m all raised to the p power, I'll use those variables today, is equal to a to the m times p. So there is rule number 2. So in tonight's homework, you need to pay attention. You may have some that are multiplying 2 numbers with the same base. You may have some that are power of a power. For sure tomorrow in your schoolwork and in your homework, you're going to have a mixture of the two. So I need you to pay attention, okay? I would definitely have your notes out in front of you so you remember what to do for each situation. Questions so far? Kira. Look at me. Say it again. So let me show you. And let me see if that answers your question. Okay. So let me give you a couple examples. And then Kira, if you still have a question, maybe you can come up with an example for me that might be what your question is. Does that make sense? Okay. So let's go over a couple of these. So I'm going to go over a very simple one, Kira, and then I'm going to do one that's a little bit more, that has more to it. Okay. So I want you guys to simplify. So if I have 4 squared raised to the 3rd power. One way that you can remember this is, if I have parentheses, when we have a number inside the parentheses and a number outside the parentheses, what does that parentheses indicate? So if I had something like 2 and then outside the parentheses 3, what does this indicate? This is just a way for you to kind of be like, oh gosh, that's right, I have to do this. Layla? Yeah, this situation means that we are multiplying. So I want you guys to think about, oh, I have an exponent inside the parentheses, I have an exponent outside the parentheses. That parentheses for the exponents means multiplication. So I should see 4 to the 2 times 3, which gives me 4 to the 6th power. Now, on a test or a quiz, I would give you probably 2s or 3s because I think those are easier to multiply, but you do need to multiply these out. However you multiply them is up to you. Off to the side, I like to just show it in expanded form. and kind of multiply from there. So 4 times 4 is 16. This is a harder one. I'm going to help us do it because it's going to take us a little bit more time. All right, 16 times 16 is going to give us 256. Times 16 is going to give us 4,096. So 4 to the 6th power is 4,096. Questions on just that basic part? Okay. All right, let's do another one. Here's one example. Here's another example. 3 times x to the 2, let's say to the 5 raised to the 2nd power. So tell me something. Your homework may not be as hard as this, but I need you to know how to do this. What is the base of the 5? That exponent of 5. What is its base? Addison? The x. All right. What is the base of the power of 2? Michaela? This power of 2? Well, so let me rewrite this. 3 times x to the 5th, all raised to the 2nd power. Put your hands down. Michaela, tell me again, what is that power of 2 on? Not just x. Everything in the parentheses. This is the base of that power of 2. Base of the exponent 2. What is the power, what is the exponent on the 3? Because if you notice, Michaela, the 3 is not in parentheses. So it's not part of the base. That 2 is just on what's in the parentheses. So what is my exponent on my 3? What is my exponent on my 3? Pierre? No. What is the exponent on the 3? Vincent, help him out. It's a 1. Because 3 is simply being multiplied by whatever that parentheses stuff is. So 3 has its own exponent. If it was inside the parentheses, and we will do those another time, if it was inside the parentheses, then 3 would be part of your base. It would be 3 times x to the 5th, all raised to the 3rd power. However, that power on that 3 is still a 1. When it's 3 times x to the 5th, it's still a 1. Sit up, please. All right, so all of you finish this. When you're done, just put your pencil down so I know you're finished. All right, someone tell me, what is, put your feet down please, what should I do here? Mateo? No, don't do it off to the side. You're keeping everything together. You are not doing anything off to the side here. Everything stays together. The moment you start putting things off to the side is the moment you either forget to put them back or you forget where they go. Do not separate things. You keep everything together. So I have 3 times. Go ahead and do the x's. So this would be 3 times x to the 5 times 2. So 3 times x to the 10th. Please keep everything together. I do not want to see this. Off to the side somewhere, you doing this. And then coming back here. I don't want to see that. I want to see everything together. Because here's the deal. I want you to look at this problem. Because at some point, you're going to do this problem. I'm not expecting you to do this right now, but at some point you will. Don't write this down. At some point, you're going to be able to do that and simplify that whole thing. If you get in the habit, Mateo, look up there. If you get in the habit of doing parts and pieces off to the side here, you're not going to know where they go. You're not going to know where they go back to. You're not going to know how they relate to each other, and you're going to get it wrong. So this eventually, more likely in 8th grade when we do more of these, this you're going to know how to do. But I am teaching you good habits by not allowing you to separate parts off. You have to keep everything together. And you're just simplifying one step at a time using your power rules. Do you guys understand how I want you guys to do this work? All right, I'm going to show you a couple that I want you to do, and then we're going to kind of mix it up between the two power rules. All right, so I'm just going to flip and give you a couple of them. I want you to simplify. Here's my first one. 10 squared, all raised to the 3rd power. Go ahead and do that. So I want you to do both of these. When you're done, check with some people by you. Use the notes that we just had from the first couple. All right, have them guide you. All right, I have one more. I'm going to add to it. So there's your 3rd one. There's 2 and 3 there. We'll go over these, and then I'm going to give you a couple that are mixed up. To me on that 3rd one how you got it. So off to the side, prove to me that that's what the answer should be. Again, when you're done, put your pencil down that way I know you're finished. you're done, check with someone sitting by you. Make sure you guys have the same answer. If you don't, see where one of you went wrong. Help each other out here. All right, let's take a look at that first one. Somebody do that first one for me. Jack? Okay. Excellent. Say that one more time. You do end up with 1 million. So 10 times 10 is 100, and this way you just kind of add another 0 each time. All right, so when we get done, we should have 1 million. How many of you guys got that right? Sweet. Someone do the second one for me. Pierre? So W, 2 to 3 times 7. Excellent. Excellent. What's my power on my -5? Frankie? 1. Okay, someone tell me, what should my power that's missing there be? Alex, how do you know that? So if I divide 12 by 3, I get 4, right? Yep. So this has to be a 4. Yes. Yeah. If you just write 4 times 3 is equal to 12, that's fine with me as well. All right, there's one thing I want to show you guys. If I have -5 squared, just want to show you this. Have I talked about this before, the difference between this and -5 outside the parentheses? Have I talked about this with you guys before when we went over exponents? We did talk about that, right? Okay, let's review that. What does -5 when it's in parentheses squared mean? What does this mean? Well, what's the base of my -5? When the -5 is in parentheses, what's my base? Michaela? Everything in the parentheses. So it's the -5, isn't it? So this is -5 times -5. What does -5 to the second power when -5 is not in parentheses? What does that mean? Christiana? Nope, because that's what this means. These are not the same thing. No. What does -x mean? What's my coefficient if I have a -x? Kira? Yep, that's -1 times x. How many of you guys remember that? So someone tell me, applying this idea to this, what does this actually say? Mateo? -1 times 5 to the second power. So when that -5, that number is not, if it's negative, it's not in parentheses, it means -1 times that. So this is actually -1 times 5 times 5. I just want you guys to understand that. Remember that, okay? All right, so I'm going to give you a bunch of these that are kind of a mix between the power of a power and multiplying two numbers with the same base. All right, and I'm going to have you do a couple of these. One of the things I want to remind you of tonight, all of you go back in your notes And I want you all to make sure that you have this in your notes. We did this yesterday or the day before. Let's review this again. I'm finding the area of this rectangle. The length of my and area is length times width. The length of our rectangle is 2 times x squared. Oh, we probably have this in our homework. Oh, we're totally putting this in our notes. So let's redraw this and let's put this in our notes. Just so you have this twice. Or something like this twice. Alright, so I want you to find the area. Alright, so do the best you can drawing. I know you don't have your rulers out. If you do, use it. If you don't, just use your grid lines. So here is our rectangle. Alright, I have 3w squared, and I have 4w plus 2. And I want to find the area. Oopsie. Let's do 4w to the third plus 2. Okay. How do I find the area of a rectangle? It's a formula. We always write it down. How do I find the area of a rectangle? Frankie? Length times width. So my length here is this 3w squared. Since the width is an expression, I have to put the expression in parentheses because I need to multiply the 3w squared times both the 4w cubed and the 2 because the width is that length is this whole thing, or that width is that whole thing. So I'm going to put in parentheses that I'm going to multiply 3w squared times the quantity of 4w cubed plus 2. Because this is the entire width. Alright. What do I have to use? What property am I using to do this multiplication? All of you should recognize this. In the past, we saw it like this. 3 times the quantity of 2x plus 1. This is just a more complex version of this. What property am I using to do that multiplication, Alex? The distributive property. So I'm going to multiply 3w squared times 4w cubed. I'm going to add to that, multiplying 3w squared times 2. All right, let's just do that first part. Somebody write out doing this multiplication of 3w squared times 4w cubed. Angela? Okay. Times. Excellent. Keep going, sweetie. Excellent. Excellent work. All right, so now that I did that one, I'm just going to put a plus symbol here because I have to do that second part. Well, here, I just need to move the 3 and the 2 next to each other. So I have 3 times 2 times w squared. So that's 6w squared. That one's pretty easy. Why am I not going to add 12w to the 5th and 6w squared? Why am I not adding those together? Frankie? They are. These are unlike terms. My hand's not doing what my mind wants it to do. Unlike terms. Do not add. All right, so you're going to need that for your homework tonight. So now you have that in 2 places. Questions on this one before I give you a bunch to practice on? Okay, so I want you guys to simplify. I'm going to put a few of them up. We've got about 10 minutes, and I just want you to work on these. So they're going to be a mix between a power of a power and multiplying two numbers with the same base. So pay attention to which rule that you need. All right. Let's do 7b cubed times 4b to the fourth. Go ahead and get going. I'm going to make the last one a little bit more challenging. I like challenging ones. Question, just ask me. Check your notes first before you ask me a question. Unless it's, what did somebody say? Consult with the notes that we've taken previously, please do that. Or don't just practice something to do it, go back and make sure you're using the rules properly. Make sure you're using some of the examples that we've done to guide you. When you're done, check what people buy you. See if you guys got the same thing. Don't separate things apart. You have to keep I've already told you this. I do not want you separating things apart. You may not do that. Erase that. I've already told you that I'm not letting you. You guys, you may not separate the numbers from the variables when you simplify ones like 1, 3, and 4. You may not separate the numbers from the variables. If you notice in examples I'm giving you, I'm not doing that. I am modeling for you in the notes I'm giving you, in the problems I'm giving you, exactly the way that I want you to do it. Just trust me and do it that way, please. I will not give you full credit if you're separating off -4 times 12 and then b to the 4 plus 7. If they're in separate places, separate lines, like away from each other, and then putting them back together. You may not do that. I know I've already said that. I need you listening and following my directions, please. There's a reason that I'm making you do that. When you're done with all 4 of these, just put your pencil down so I know you're finished. On that last one, which power rule do you need to start with first? Because there is an order in which you need to do that. Which power rule do I need to start with first? Kira? I'm sorry, Layla? You do. You have to do the power of a power first on number 4. All right, you've got to get rid of that power of a power first. It's almost like order of operations still. Remember, we've got to get rid of exponents before we can do multiplication. It's still the same here. Now it's just in a different format because now we're dealing with exponents of like power rules. But the rules still apply for the order of operations, okay? All right, somebody do, I'm going to rewrite that. So I have 7b cubed, 4b to the 4th. 7b cubed times 4b to the 4th. Somebody do this first one for me. Audrey, do this for me. Okay. Excellent. So I'm just going to remove those terms next to each other. Keep going. Yep. Times or plus? Times or plus? Plus. Remember, we're multiplying 2 numbers with the same base, which means we keep the base and we add the exponents. Remember, pay attention to which power rule you have. And when I'm done, I get 28b to the 7th. I want all of you looking at number 1. This is exactly the work that you should be seeing. You're not seeing me do this. And then putting it together. I do not want you doing that. I want you keeping everything together. Nice job, Audrey. All right, the next one was 2 squared to the 4th power. So 2 squared all to the 4th power. Somebody do this one for me. Vincent? Excellent. To the 8th power. And when you did 2 to the 8th power, I'm going to put a little dot, dot, dot. What did you get? 256? How many of you guys got 256? Sweet. All right, nice job. My next one was negative 4b cubed, 12b to the 7th. Negative 4b to the 4th times 12b to the 7th. Somebody do this one for me. All right, Kira, you're up. Excellent. 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 Really nice. All right, how about that last one? Let me write it down. So I have 2x squared times 3 times x to the 6th, all raised to the 10th power. All right, Romano, you're up. I'm listening.
2x squared times 3, and then times x, and then 6 times 10.
All right, so I have 2x squared times 3 times x to the 6 times 10. Excellent.
And then that equals 2x squared times 3 times 60.
All right, so I have to the 60th. 2x squared times 3 times x to the 60th. Sweet. Now what?
And then you put 2 times 3
Yep.
times x times 60. No, x squared.
X squared.
Times x.
Excellent. I know, right?
And then 6x squared plus 60.
Okay.
And then that equals 6x plus 67.
Excellent. Nice job. How many of you guys got the 4th one? Awesome. Okay, so tell me something. What is the hardest thing about these? God bless you. What is the hardest thing about these? Frankie?
Switching back and forth with like x is 6 and outside 10. And then like not having parentheses and having.
Yeah, so it's you're switching between the 2 different power rules. All right, so it's just a matter of really paying attention to what you have, because the harder these get, you are going to have to switch between which power rules do I need. So just focus on what it is that you're simplifying. You're doing one thing at a time. If you do too many things at once, you are going to get confused. Keep it all together, please. You guys cool? Okay, you guys can go. Nice job today, you guys.